So we're back in this part 2. We're going to look at some of the other contacts that we didn't quite fully cover. We're going to look at some of our outputs. So on the left side of this board, and that can vary left or right depending on the model, but on the left side of this board we have a number of different output contacts. The top is the circulator. Now that circulator is not the variable speed circulator that we would use to bring the iFLOW or water into the iFLOW. This would be a 24 volt output on a heating call that would typically be wired to a relay that will bring on your primary loop. So if you're using a boiler with a primary, secondary, and you need a signal to bring on your primary pump, that is where we would take the 24 volt signal to a relay and then power your pump, your primary loop pump. The secondary pump, or the pump that's bringing the water into the iFLOW, will connect to this C1 and N contact. So the C1 will be the hot and the N will be the neutral for that pump. We're supplying the variable speed pump control from this red colored wire that's supplying C1. So just to give you a look at that, we'll bring back the computer, but so that's the circulator. Then we have dehumidifier, which we're not using yet. That'll be for a future component that we're going to be incorporating into the iFLOW package. We have the humidifier contact. So that is going to supply 24 volt output to your humidifier on a heating call when your humidity sensor sees a temperature lower than the set that you have programmed into the board. Below the humidifier we have O, C, and B, or heating W1, C, and W2, but this is for your heat pump reversing valve. So when we're using a heat pump, we know that the Y1 will then be calling the compressor on, but depending on whether we're in heating or cooling mode as default, we'll need to send a signal out to the reversing valve to switch over. So that's what we use the O, C, and B contact for, or the W1, C, W2 on the output, right? Obviously our heating thermostat inputs, W1, W2, are on this side. This is the output, but only for heat pump. And then we get into our boiler TT. So then we have a dry contact there. So when we call on, when we get a call for heat, if we're running with a boiler, this is the dry contact that would connect to your boiler. And that's it. So let's bring the computer back in. And we'll slide this in front and try to go through some of that. So as I mentioned, the circulator contact, and again, this is 24 volt output for your primary loop circulator, would be there. Below that is the dehumidifier. So again, we're not using that. That's for future integration. We have the humidifier output. So again, that's going to send 24 volts, and it's energized in heating mode when the humidity rate is lower than the value that you have set in the parameters. The default parameter is 45%. Below that, you have the boiler TT. And again, it's just a dry contact or dry switching relay contact that's used to activate the boiler or the combi if we're running that. And again, as I mentioned, below that we have the OCB. So O, or W1, right? It supplies 24 volts to the heat pump reversing valve for a call for heating when the heat pump is default cooling. The B, or W2, supplies 24 volts to the heat pump reversing valve for a cooling call when the heat pump is default heating. So again, it's important to know whether your default is heating or your heat pump is default heating or cooling. To do that, just call on the compressor. Call on the compressor and see what temperature it's delivering to the evaporator. So feel the line set. Is it delivering heat or is it delivering cool? If it's delivering heat when a call for the compressor comes on, then the default is heating. If it's delivering cooling, then we know the default is cooling. So why do we need that? Well, if the default is cooling, then we know when we call on the compressor at Y and C, then the compressor is going to deliver cooling. When we go into heating mode, then we know we need to change the reversing valve. But if the heat pump is in default heating mode, then we know when we get a call for cooling, we will need to energize the reversing valve. So it really depends on what the default is and what we're trying to achieve. Below the heat pump, below the OCB heat pump connections, then we have our AC compressor. Excuse me. And that's a compressor call on. So we'll just send 24 volts out to the compressor. And that could be the AC or heat pump when there's a call for heating or cooling. So if we're just running AC, of course it's only going to be a call for cooling. So when there's a call on the Y at the thermostat, we're going to send 24 volts output to the AC compressor. If we're running with a heat pump, then it could be heating or cooling. So when we get a call for either, we're going to bring on the heat pump, bring on the Y1C, for example, and then send power to the appropriate O or B, depending on which kind of unit we're using. On the right side, we have our thermostat connections. We didn't look at them that closely, but here's kind of the two. So this is a 2-zone option. If we had 4 zones, well, it would just be more of the zone 2, zone 3, and zone 4 would be just replicates of that. On our zone 1 contact, we have R, W1, W2, G, Y1, Y2, and C. We can run with any communicating thermostat. We do supply the C for if it needs constant power. So not a problem at all. For zone 2, we supply R, Y, or R, W, G, Y, and C. So each of your zones can have a communicating thermostat. In terms of Y1 or Y2, W1, W2, it really doesn't matter. Our system will look at it and adjust the delivery, CFM delivering accordingly. But in some cases, if you have a 2-stage AC unit, for example, you might want to use Y1 and Y2 and set the different levels. So it's just giving you a little bit of extra flexibility there. But then the other zones are R, W, G, Y, and C. So that's what the contacts look like. When I see 2 or 3 wires connected to one contact, typically that's a no-no. You should only have one contact in because, again, we're not taking any power off this. We're running all of our outputs, for example, our AC output to our compressor. That's run from the output contact, not from we're not stealing it from the Y1 contact here on the thermostat. So be sure that, you just have your wiring from your thermostat in, and that's all you need, nothing out. Now, with regards to heat pump thermostats, on the heat pump thermostats, you can have, emergency heat from, that's usually an E. You have auxiliary. You can have O, B, and coming directly from your thermostat in. We don't need any of that. Just turn your heat pump thermostat to conventional mode. Just run it with your 4 or 5 wires in. We will then decide, do we operate the heat pump or do we run the backup? So that the iFLOW will decide, and it will send the signals accordingly. It does not need the thermostat to do that. So this is where a lot of the wiring confusion comes in. So just bring your regular contacts in, and that's all we need from the thermostat. So you actually don't need an expensive heat pump thermostat. You can just run with a conventional thermostat without problem at all. So once everything is wired in, this is kind of what it will look like. This is our 4-zone controller, and we've got our outdoor sensor connected. We've got zone 1, zone 2, zone 3, and zone 4, each with their own contacts. On the bottom, we have all of our zone dampers. So we have On our system, we can accommodate for one supply damper and one return damper for each zone. And then in each of our dampers, we have a temperature sensor. So we have a sensor in the supply damper and a sensor in the return damper. So if you're using just one supply damper and a common return, then you can just ignore the return damper connection and the return sensor connection. You won't need those. But if you do run with the return damper, then you can connect them accordingly. So supply damper, return damper for zone 1, supply sensor, return sensor for, again, zone 1. And then you do the same for zone 2, zone 3, zone 4. The nice thing is everything is wired into the iFLOW controller. You don't need any external zone controllers or anything like that. Everything comes in directly to the iFLOW. You can also see in this picture we have the Navian iFLOW Navian communication cable connected. So looking a little bit further at the wiring, again, as I mentioned, all your thermostats will come in on, let's say, on the right side. If we're looking at the at this board as an example, all your dampers will come in the bottom, right? Zone 1, zone 2, zone 3, zone 4. They'll all be, and then they've got this kind of legend. So you see we have supply damper open, COM, and supply closed. And then return damper open, common, and return closed. And then for the sensors, we have the supply sensor and the return sensor. Each is a 2-wire, but they'll share the common. So supply sensor temperature to common, and then return sensor to common. In terms of wiring the pump that's supplying the heat to the iFLOW, on a primary secondary design, it'll be a secondary pump that you connect to the C1 and N. If it is a single circuit, then with an external pump, then you will wire that external pump on the single circuit to this connection so that iFLOW can control the flow of the pump. So this wiring, this C1 and N contact from our main contact block goes directly to the circulator that's supplying the iFLOW with the hot water. You would not use this AC 24 volt circulator contact for that pump. This would be for your primary loop pump if you're using primary secondary design. So just to hammer that point home a little further, again, from our pump, we're going to wire that in, and that's going to be this pump that's supplying the hot water directly to the iFLOW in this wiring diagram, or this piping diagram, for example. So this would be your primary loop pump. So if the boiler did not have primary pump control, then you could use the 24 volt from the circulator output contact through a relay, 24 volt to 120 relay, to power this pump up. But the pump that's supplying the water to the iFLOW, which is on a secondary in this case, that would be wired directly to the C1 and N connection on the iFLOW. The iFLOW dampers, we have both round and square rectangular types. We've got 6, 7, 8, 10, and 12 inch diameters on the round, and 8 by 8, 8 by 10, 8 by 12, 14, 16, and then 20 and 24. The 8 inch is on the rise. The length is variable, and then the depth is 4 inches. But nonetheless, we're talking about the wiring in this section. So you can see here by this graphic in the middle, perhaps, that we have the temperature sensor, and then we have the open, COM, and closed. So we have 2 contacts for the temperature sensor, again, one common, one, and then we have the power open, common, and then power closed. We also have, as you see below, we have, regardless of whether it's our round dampers or whether it's our square rectangular, we have a temperature sensor in each one of them. So when the damper opens up, we can actually detect the temperature in each of the zones. And this is used in our smart mode design, where we can actually measure exactly what's coming in on the supply and return for each zone. And then we can mix zone temperatures and do some other fairly creative stuff. But that's what the sensor's for, and that's where they're located. So let's go back to our diagram and see how we wire that. Well, our zone thermostats would just wire into the board on the right, as we saw earlier. But our zone dampers would connect to on the bottom, and you can see kind of the connections here. So you have your supply open for zone 1, your common supply closed for zone 1, and then you have the return damper if you're going to use it, and then you have the temperature sensor for zone 1 with the common, or the return sensor with the common for the return damper sensor. So again, that's what the contacts look like, and then they would wire accordingly this way. So your supply damper, open, common, closed. Your return damper, open, common, closed. Your supply sensor, temperature, common, and then your return temperature sensor, common, and then return sensor, temperature. So hopefully that's straightforward. Hopefully it's laid out well enough in the manual. This is kind of how it wires in. So again, from the COM, open, and close on the damper, you would wire then appropriately to supply open, COM, supply closed, and then return for the same, or the same for the return damper. So that pretty much covers all of the contacts that I wanted to show you. Again, if we come and do a little bit of a close-up, the zone dampers would connect on the bottom. So the zone dampers would all connect here. So this again is a 2-zone unit. So zone 1, zone 2, and then your thermostats, zone 1, zone 2, your outdoor sensor, your flow switch, and then all of your outputs on this side. So we talked about the output to the compressor, output to the heat pump, your TT to the boiler, your humidity sensor, your humidifier output, your dehumidifier, which we're not using, and then your 24 volt to your circulator. And then as we looked at, we've got the C1 and N to our pump that's supplying hot water to the iFLOW, and we're modulating or controlling the variable speed through this red contact. So we can make a single speed pump, a variable speed pump, by varying the power to the motor itself. So that is a basic overview of all of the componentry and the wiring to the iFLOW board. Hope you found it helpful. If you have any questions, by all means reach out, and we'd be happy to answer your questions. Again, thank you for your time, and we appreciate it. Take care.